Let's now look at the first one of these examples that we'll cover here. It's the one on the top of the screen. Last year, 78% of 120 UAB students taking the CPA exam passed. This year, 91% of 85 students passed. Construct the 95% confidence interval for the true increase in the proportion of UAB students that pass the CPA exam. Alright, like the previous example with averages, this asks for an increase, and so we're going to have to do this year is group sample number 1 and last year group number 2. That's the only way we can work an increase. Alright, let's write down our information. So this year we have 91% of 85 students. So this year N1 is 85, sample proportion, alright, 0.91, 91%. Last year we have 78% of 120 students. So N2 is 120, and we had 78% there. Okay, so if you take the difference, p hat 1 minus p hat 2, 0.91 minus 0.78, 0.13, we have our increase. All right, it increased from 78% to 91%. The increase was 13%. Problem asks us for a 99% confidence interval for the true difference in the proportions. Formula for that is the sample difference, which I just showed you. P hat 1 minus P hat 2 plus or minus the appropriate Z value that gives us 99% in the middle times the standard deviation. Alright, sigma hat's of P hat 1 minus P hat 2. Alright, so 99% confidence interval means that we have the middle 99%, half of 99% is 0.495, so we get 0.495, 49.5% here, 49.5% here. Alright, so 0.5% in each tail leads us to 50% on both sides. Alright, so we're going to go to our Z tables, look for the number or the value closest to 0.495, and then we will find our Z value. Alright, 495. Okay, I've got it marked here. 495 is somewhere between 4949 and 4951. It's on the 2.5 row and in the 0708 columns. Alright, so just to be certain, the confidence interval will include too much, that'll be a Z value of 2.58. Standard deviation, sigma hat's of P hat 1 minus P hat 2. P1 hat times 1 minus P1 hat divided by N1 plus P2 hat times its complement 1 minus P2 hat on N2. Alright, just so that you can see the data. Alright, P1 hat is 0.91. Its complement is 0.09 divided by the sample size there of 85 plus P2 hat's 78%, 0.78 times its complement, 0.22 divided by the sample size there of 120. Okay. And we'll go to Excel and work that out. So square root of 0.91 times its complement 0.9 divided by 85 plus, and then p hat 2 of 0.78 times its complement, oops, that's 0.22 divided by sample size 120, close parentheses, and that's 0.4892. Okay, and then we can calculate the 99% confidence interval for the true difference in the proportions. Alright, the sample difference, p hat 1 minus p hat 2 is 0.13, plus or minus the z value, 2.58, times the standard deviation 0.4892. Alright, and let's again go back to Excel and work that out. So it's equals 0.13 minus 2.58 times the standard deviation, number very close to 0, and then 0.13 plus 2.58 times the standard deviation. Alright, it's close to 26%. So 0.3777 for the lower limit to 0.2562. Alright, and that's our confidence interval for the true difference. So even though the sample increase was 13%, right, went from 78% to 91%, the true proportion at the 99% level of confidence is somewhere between a number very close to 0 or no increase to 25.6%, which is a huge increase. Can't do that very much, can it? So in any case, not a very accurate estimate, but that once we have a confidence interval, then we have some idea of the strength of our estimate. 13% looks strong, but once we've calculated this confidence interval, we have second thoughts about how strong it could be. It could be really strong, or it could be not strong at all. But there is some increase, apparently. Alright, and that's that problem.